How to get p-values less than 0.05 in biological research. Chapter 9. Avoid chi-squared tests when you have ordered categories. Use CMH tests instead. When you have tables with ordered categorical variables, the Cochran-Mantel-Haenszel CMH test for ordered categories will usually give smaller p-values than a chi-squared or Fisher exact test. Here are two examples of tables with ordered categorical variables, showing counts of the number of subjects in each category. Example 1. A clinical trial of a cancer drug in which the possible outcomes are the ordered categories: no remission, partial remission, and complete remission. Example 2. A clinical trial of a cancer drug in which the rows are the ordered treatment categories placebo, low dose, high dose, and the columns are the ordered categories no remission, partial remission, and complete remission. Both rows and columns are ordered categories. Published articles sometimes report non-significant results when the researchers use a chi-squared tests for tables that have ordered categories. The CMH test would provide more power and better p-values for these analyses. The Cochran-Mantel-Haenszel CMH test extends the chi-squared and Fisher exact tests in two ways: tables with more than two factors, stratified analyses, and tables with ordered rows, columns, or both. Example: CMH test for table with ordered columns. We'll use the CMH test function from VCD Extra Package. Consider a clinical trial of a cancer drug versus a placebo in which the possible outcomes are the ordered categories no remission, partial remission, and complete remission. Here is the data set. Here is the resulting table. The chi-squared test and Fisher exact test ignore the ordering of the columns and return non-significant p-values for this example. Let's start with the chi-squared test, which is commonly used. The sample size is quite small, so the Fisher test is preferred over the chi-squared test. The chi-squared output gives a warning that the approximation may be incorrect. Next, try the Fisher exact test. We get a non-significant result for both the Fisher exact test, p equals 0.1135, and the chi-squared test, p equals 0.069, but not reliable due to small sample size. In contrast, the Cochran-Mantel-Haenszel CMH test uses the fact that there are ordered rows, columns, or both, which increases the power. In this example, it gives a significant result. Here is the interpretation of the output. 1. The row labeled core is used for tables where both rows and columns are ordered. We'll look at an example shortly. 2. The row labeled R means shows the result testing that the row mean scores differ for drug versus placebo. The CMH test gives p equals 0.0248, indicating that drug and placebo differ significantly in outcomes. 3. The row labeled C means would apply to tables in which the rows are ordered but columns are not ordered. 4. The row labeled general is similar to the chi-squared and Fisher tests. The p-value of 0.0248 for the test that row means differ indicates that there is a significant difference between the drug and placebo groups. Example: CMH test for table with ordered rows and columns. Consider a table showing results of a clinical trial of a cancer drug as follows. Rows are the ordered treatment categories placebo, low dose, and high dose. Columns are the ordered categories no remission, partial remission, and complete remission. Both rows and columns are ordered categories. Here is the data set. Here is the resulting table. The chi-squared test. and Fisher exact test ignore the ordering of the rows and columns and return non-significant p-values for this example. The Cochran-Mantel-Haenszel CMH test uses the fact that there are ordered rows and columns, which increases the power. The row labeled core in the output applies to tables where both rows and columns are ordered. We examine the row labeled core. The CMH test gives p equals 0.032, indicating that the treatments differ significantly in outcomes. Contrast this significant p-value to the larger and non-significant p-values obtained when using the chi-squared or Fisher exact tests that do not use the ordering of the columns and rows. Watch out for which CMH test your software is performing. There are several different statistical tests that are sometimes called a Cochran-Mantel-Haenszel test and sometimes called a Mantel-Haenszel test. In some software packages, the names Cochran-Mantel-Haenszel test or Mantel-Haenszel test do not refer to the test for ordered categories, but instead refer to a stratified version of a chi-squared test. An example of a stratified test would be when we want to look at the relationship between, say, drug and placebo versus responder, non-responder, but want to stratify by, say, sex. Then there are separate tables of treatment versus response for each sex, and the CMH or MH test calculates a chi-squared statistic that essentially pools the tables together. This analysis is clearly not the same as having ordered rows or columns, but unfortunately, the naming convention doesn't always make it clear which test the software actually performs. You need to read the documentation and/or run some example data where you know the result. Visit mwalkerstatistics.com to download our code for all examples and get the free companion book in PDF format, or order a copy from Amazon.